This video is going to teach you how to do a combined gas law problem. Now, this particular gas law is going to be different than the ones that you've worked on previously because in all of our other examples, we've only compared two variables changing at one time. In the combined gas law, three things are going to change. In combined gas law, the variables that will change are pressure, volume, and temperature. All three will change. The only thing that will stay constant is the amount of gas, N. Now, the equation that we can look at, if you were to try to do this with equations, is that you could take P times V divided by the temperature would equal some constant K. And if you really do like doing these with equations, there's another video that teaches you how to use the equation to solve these problems. I prefer doing this based on relationships. And what I would say is, when you're doing these problems, only focus on one variable at a time. And I'll show you what that means by doing this example problem. If you look at the example problem, it tells you that a certain gas occupies a volume of 550 milliliters at a temperature of 27 degrees Celsius and a pressure of 750 millimeters of mercury. The question is saying, what volume will it occupy at STP, standard temperature and pressure? So if you notice, the volume is going to change, so is the pressure, and so is the temperature. So you're going to make a chart. It doesn't matter what order you put the variables in, but you're going to have all three of them listed because all three of them are changing. So if you read the first sentence, it's telling you that it has a volume of 550 milliliters when the pressure is 750 millimeters of mercury and the temperature is 27 degrees Celsius. Now you want to remember that whenever you use temperatures in gas law problems, you have to remember that they can only be recorded in kelvins. So you have to add 273 to 27 to get a temperature of 300 Kelvin. You cannot do the problem if it's in Celsius. Then if you read the second set of problems, or second sentence, it's asking you to find the volume. So the volume will be my question mark in statement 2. And it's saying at STP. So you have to think here. Standard temperature and standard pressure. What is standard pressure? Well, if we look at millimeters of mercury, and you go back to the very front of your pink packet, it tells you that standard pressure is 760 millimeters of mercury. We want to use the units that match. If you look at your standard temperature is always 273 Kelvin. So we want to know what's happening to volume. In order to find this answer, you're going to do the same kind of math you've been doing. This time, however, instead of multiplying by one fraction, you're going to multiply by 2. But I always want you to focus on just one fraction at a time. It doesn't matter which one you do first. So if you look at the volume, that's the one you're going to change. Look at pressure. Pressure is going from 750 up to 760. Now remember your relationships. If P goes up, V must go down. That's what Boyle's law states. So we want to multiply by a fraction that would make this number go down. The fraction we're going to use, we're going to put the small number on top, 750 over 760. That will make the volume go down. Now that you've dealt with the volume, you can ignore now that you've dealt with the pressure, you can ignore pressure and move on to temperature. Do that as its own separate fraction. The temperature starts at 300 and drops down to 273. When the temperature drops, according to Charles' law, when the temperature drops, the volume should drop. And so what we're going to do is take the 273, the smaller number, over the bigger number, because we want that volume to go down. Now all you have to do is some math in your calculator, and you should get a final answer of 494 milliliters for your volume. Now what you can do is try the learning check which is written here below. Check your answers online. And if you're still struggling with this, make sure you bring your questions to class so that I can help you.